Solving exponential equations. These are examples from your 7.2 note sheet, so please look at your 7.2 note sheet. So to start with, what is an exponential equation? An exponential equation is an equation where x is the exponent. We need to solve for it. We have a little song, x is the exponent that makes it exponential. So when you have your variable, which in this case, most of our cases we're dealing with x, located in the exponent, this an exponential equation. So in order to solve these exponential equations in this section 7.2, we're going to be using the common base property. So that states if you have two bases, two numbers that are equal and they're being raised to two different exponents, what can you say about those exponents? So here we have an equal sign, 2 equals 2. Well, that means that x has to equal 3. So there we've solved for x. So this is a very simple version of our equations. If we take a look at numbers 3 and 4, here these are not as straightforward. In order to solve these for x, we're going to have to use some of our other properties of exponents. Also in class, we made lists of all of our bases where we have 2 to a bunch of different powers, 3 to a bunch of different powers, 4 to a bunch of different powers, 5 to a bunch of different powers. That's going to make this section a lot easier. So to start with, looking at number 3, we have base 5 being raised to the exponent x equaling this fraction. So one thing that I do is over here in our tips, my first tip here is, can you write the larger base as a smaller base to some exponent? So here our larger base is 125. Can we write that as our smaller base 5 to some exponent? And we can. 5 to the power of 3 is 125. So the left side we're keeping as 5 to the power of x equals 1 over, and 125 we're going to rewrite to be 5 to the power of 3. Okay, and all I'm doing is I'm just taking 125 and I'm rewriting it. So these are equivalent equations. So now, in order to use this property that I talked about over here, our bases need to be in the same location. We had 2 equaling 2. Over here in this example, we have 5 on the left located, it's not a fraction, so it's kind of like it's over 1. And over here, 5 is in the denominator. So using our negative exponent property, what we can do is move that to the top of the fraction. And when we do that, we just need to change the sign of our exponent. We usually use this property when we have negative exponents, like if we have x to the power of negative 7. Negative exponents are generally a no-no, so you would move that to the bottom and it becomes positive. Well, similarly, I could take that, move it back, and now it's a negative exponent. So over here, we're going to take that 5 to the power of 3, move it to the top, and now it becomes 5 to the power of negative 3. So we have 5 to the power of x equals 5 to the power of 3. 5 equals 5, which means that x has to equal negative 3. So there we have it solved for. Okay, number 4 is a slightly different version of this, where now we have a fraction being raised to the exponent, and that's equaling another fraction. So similar kind of idea where I'm going to still use this tip. Can I write my larger base as a smaller one? Only thing is now I'm looking at 16. Can I take 16 and rewrite it as 3 or 2 to some power? Can I take 81 and rewrite that as 3 or 2 to some power? So looking at my list of bases with exponents, I see that 16 shows up on a couple different lists. 16 is 2 to the power of 4. It's also 4 to the power of 2. 81 shows up also on a couple of lists, so this is 16. 81 shows up on a couple lists. It's 9 squared, which I guess isn't one of our lists, but I know that 9 squared is that. Also 3 to the power of 4. Well, on the left side here we have 3 and 2, so I'm going to use 3 and 2, and I can see those are both being raised to the power of 4. Which is good, because then I'm going to have these raised to the same exponent. So the right side, I'm going to take 16, rewrite that as 2 to the power of 4. 81, rewrite that as 3 to the power of 4. and this equals 3 over 2 to the power of x. So looking at these, I have the same numbers. I have 2 and 3, but the issue is they're in different spots. So I'm going to move both spots on the right side. So I'm going to move 3 to the top. That's going to change it to a -4. I'm going to move 2 to the bottom. So that's going to change that to a -4. And that equals still 3 over 2 to the power of x. So now I have 3, 3, 2, 2, but what I need to do is get this to be one single fraction of 3 halves. Since these are both being raised to the power of -4, what I can do is kind of factor out that -4, and that's using our quotient property, or power of a quotient property kind of in reverse. Okay, and now we have 3 over 2 is equal to 3 over 2, which means that x has to equal -4. Okay, so these are just two examples of how to solve exponential equations.